Rust syntax and programming style is what makes it difficult to learn. However, it's also what sets Rust developers apart from any other developer. And since Solana is programmed in Rust, this gives you the chance to be part of a relatively small group of talented programmers. The most important thing to understand when learning a new programming language is sort of what makes each language similar to each other. So, what goes into every programming language that makes the rules and syntax for that language? Now, I'd like to go over the most basic forms of data structure for Rust before making things any more complicated so we can get sort of a general understanding for how we're going to be developing code. Now, Rust may have syntax that's a little bit more difficult to understand than other programming languages, but it's worth it for the speed and efficiency it brings. Now, to get started, I'd like to go over variables, data types, and functions, some of the most simple rules for programming languages. So to get started, I'd like to go over these four basic data types. So we have integers, floating point numbers, booleans, and characters. So first off, integers. Let's take a look at the syntax behind defining an integer and really any variable in general. So we have let in equal 10. Now let's take a dive into what's going on here. We have the first word, let. That's basically letting Rust know that we will be defining a variable, and then we set it equal to a number. And that is the syntax for defining an integer. Now, what do we have down here? We have sort of a colon and a U32, which is different than what we have up there. So this type of definition is very specific to Rust in that in C or C++, you can define the data type and that's necessary. In Python, you don't need to define the data type at all. In Rust, it gives you the option of defining the data type. And so for U32, this just means that we have a U32 integer, which sort of specifies the length. So this would mean 32-bit. Now we could do the same thing for, let's say, a U8 integer, which would be 8-bit instead of 32. Now on top of that, we have the U. Now what does this little U mean right here? So the U stands for unsigned. Now you can probably guess what this means, but this just means that the integer will not have a sign, so it can't be negative. It will be anywhere from 0 to a very large integer. We could do the same thing with signed, except instead of U, it would be a little bit harder to guess. We could say I32 as a signed integer that's 32 bits long. Now, floats will be very similar to integers. Now that we're done with integers, we can put this away. In that floats will have decimal accuracy as well. So we can have 0.1 and 0.4. Now, the only difference with specifying data types for floats is we'll have F64 instead of, for example, U or I, 64 or 32. And this just means that it's a floating point number, so it has a decimal and it's 64-bit length. Other than that, all the definitions for float, besides the FL instead of IN, will be very similar to integer. Now, with Boolean, it's a lot simpler. So we are just going to either say let tr as in true equal true, or let fl as in false equal false. And Boolean will only have those two options for defining them. And also I should mention that the names of these variables, although in this case are very similar to what they're defining, does not matter. So we could have, let's say, let dog equal true, and this will give us the same type definition as let tr equal true. It will still be Boolean because Rust can see what you're setting the variable equal to and determine that it's a Boolean, and it doesn't need any definition like we have up here, or we would put here, specifying that it's a Boolean. Now, moving on to characters. As you can see here, all we need to do is say let some variable name, let's say cr equal to, as we do here, we have a, and notice how we have single quotes. Now, what happened if we said let cr equal to double quote aa? This would be a little bit awkward because for Rust, double quotes are strings, not characters. If you just want to do a single character, like a letter or an emoji, then you use single quotes when defining. And the only difference down here, we have let cr with the colon car equal to the glass emoji face. That's just specifying that it's a character data type. Now, the only thing that we have different down here is we have let cr colon car equal to this emoji, and that's just specifying that we have a car data type down here. So in this lesson, we learned how to deal with scalar variables So this means anything from Boolean to integers and floats and characters as well. And in the next videos, we'll learn more ways to organize this data, such as classes. And with this, you have a very solid foundation for programming with Rust, knowing how to compile and run files, along with the initial definitions of the syntax rules for scalar variables. So great job so far, and definitely try and get a handle on the basic syntax before moving on. Happy programming.